All right, thank you for joining me today. This is going to be week 4 of our beginners bootcamp. I think we covered a lot of great things, and we're just going to build upon what we built last week with our plotting and our descriptive statistics and things. And we're going to be able to today we're going to learn how to make our own code that can make decisions like if-else statements. We'll learn how to handle functional programming topics in R, as far as like for loops, while loops, and we'll learn how to make our own actual custom functions that we can try to implement in our work. And really the theme of this whole thing is going to be R has advantages, and we can use these vectorized alternatives to make faster and easier programming decisions in our workflow. That's the whole point of using R in the first place. So just to get off, we'll start off by loading our packages. Nothing special today. String or Liberty just for some data handling. Really just pulling the tidyverse today is a lot of what we're doing. So first, making decisions with if-else. So just this are very basic programming concepts. You might be new to some of these concepts. They might be obvious to you. If they're obvious, I apologize. If they are new, then just keep it simple. This is the foundation of a lot more complicated programming concepts. So think of if statements as like making a decision in real life. Like if something happens, then do this, right? If it's raining, then take an umbrella. And so like for example, is the number big or not, right? So a number is going to be defined as 10, and we're just going to have a simple statement, just one statement. If something, then do this, right? So if number is greater than 5, which it is, then print this number is bigger than 5. If it wasn't bigger than 5, nothing would happen here, right? Really simple. If age equals 20, if age is greater than or equal to 18, you can vote, right? So 20 is greater than 18. Once again, you print out the statement. So that's one choice, or just one condition, right? What if there's two choices? Sometimes we need to do one thing or another, right? Depending on what's happening, right? So once again, let's say age equals 16 this time. Now we're saying we're doing exactly the same thing here. This is the same text, right? If age is greater than or equal to 18, then print, you can vote. But now we want to do, what if it's not? Before, if it wasn't, it just nothing would happen, right? But now we want to say something, right? So now we say else do this. So if age is greater than or equal to 18, then print, you can vote. Otherwise, else print this, right? It's not, so then we get the second version here. Same with the temperature here. If temperature is greater than 80, which is not, then we skip the if statement and we print out the else statement once again. So it's if it's that, it's not, else it's that. Well, then we print the outfit, right? And here we've defined actually a variable here to return. And print can return these these values, or you can just type in outfit by itself and hit enter. It also gives you that. What if you have multiple choices, like 3, 4, 5 choices? Well, one basically you can do it, just keep stacking if-else statements. So this is one statement, this is one statement, and so on. So if score is greater than or equal to 90, then grade equals A. Else, if it's less than greater than or equal to 80, then grade is equal to B, and so on and so forth. If it's none of those, else it's F, right? We put in 85, it's going to be between 90 and 80, so that's going to be B. It's going to print out your grade is, and grade was defined as 80 based on this condition and print it out. So there you go. There's the if-then statement. So how can R help us in this at all? Well, if you have one condition that if this, then that, you pretty much have to go with the if statement. There's no faster way to do it than that. However, if you have the multiple conditions, you can use R and use more simple functions to present the data and work in a simple manner. So let's just do the if-else statement, right? So we want to say basically here we have a vector of scores basically. So we have multiple scores here. Then we can use the statement, this function in R called if-else, and we're basically just saying if scores are greater than or equal to 70, then say pass, else do fail. So the first score is 95. It's going to be greater than or equal to 70. You're going to have pass, right? The last one's 65. it fails this condition, so that you're going to have coincidentally the fail the print here, right? So you can see here we're able to pass a vector. Now we could have just put one number, right? But now we can pass a vector of values into this if-else statement and get a really quick answer here. That's much cleaner and easier than seeing that if else stacked basic computational way of doing it, right? So what about if you have multiple things, right? Multiple conditions. Well, before I think we've seen the case when, right? So we've used this before. So we're just saying case when this, do this. Case when this, do this. Same with this. Otherwise, do this, right? That's all it's saying here. We created this data frame here on the top. It's pretty easy just to look on the bottom here, the name score, the first two columns. So we're basically saying Alice is 95. Well, if Alice is greater than or equal to 90, then score is equal to A. And that's why you're getting a grade here of A. Where Eve is less than, so she's getting an F. Now you also have a status here where we have an if statement. So we're just saying if over 70 is equal to pass. It's the same as above, right? So 95 is greater than or equal to 70, so we get the pass here. And that's how we get. So by printing the students' result, we're able to get our results data frame there as well. So when do we use what actually? So remember, we're checking one value. Just use the if statement. It's not even really else. It's just if, right? If do this, then that, right? If you're doing multiple values, use the R version, the if else. It's just much easier, right? We're checking many values, multiple conditions, then you use your case when. Now let's talk about repeating tasks. This has just been conditional so far, right? Well, the two basic things in programming are conditional and loops, right? So for loops, you want to just repeat something over and over and over again, so you don't have to just run it individually 7,000 times or whatever, right? So there's just a simple loop, right? It's just saying for something in something, basically, for I in 1 through 5. Basically, just for each one of these values, do this, right? So we're just saying we have 1 and 5, right? So that tells us we have 5 different things. Now, we're using a variable I. It could have been anything, right? But we're just saying for each I in 1 to 5, return I, print I, right? So for 1, it just goes here, and we print counting 1. For 2, it goes here, and so on, right? So for each value till it gets 1 through 5, we get this return, right? So we have 5 different objects. It kind of makes sense, or results. We can also, have a vector of different, character values, for example, right? Let's loop through these names. It doesn't have to be numbers, right? So we're going to call these friends, right? This is a vector of friends, just like 1 to 5 is a vector too. So you basically have this vector for each value in the vector. So for each friend in friends, right? Let's do this, right? So the first friend is Alice. The second is Bob. The third is Charlie, right? So we're just looping through those character values, right? Finally, just doing returning an equation here. We have a practical example here. Just calculate the squares, right? So our numbers are 2, 4, 6, 8, 10, and our squares here, we're just basically making, when we have a function like this with I on both sides, we have to have an empty vector first. So we're basically just saying there's going to be 5 numeric values. So 5 numeric values, but it's going to be an empty vector, right? Then we're going to populate this data frame. So squares is just a numeric vector we're populating, right? And then we'll data frame it into number squares for our result here, right? So for I in 1 to 5, right? So now 1 to 5 is not 1, 2, 3, 4, 5. You see it? Numbers is the vector, right? We're subsetting that vector now. So 1 to 5 is a subset now. So the 1 goes in here, right? And 1 is equal to the first value, which is 2, right? So 2 squared equals 4. Just like the 5th value is 10. We subset that for the 10th value. 10 squared equals 100. So that's just another way we can loop through these things. But this is ridiculous. Why are we doing this, right? R already does this by itself. That's the whole point of R, right? Vectorized operations. We don't need a for loop. So look at here. We already have the vector, right? Well, let's just square the vector. We can do operations on vectors already. We don't need to throw vectors through for loops. So our squares here, we could just done an operation of square on our vector, right? Here, if we want to find the 90% of the prices, then we just multiply 0.9 times each of our prices in the vector. Or here we multiply by 1.8. But the point is we're just doing operations on the vectors already. That's basically what we have. We have a vector, it's like a column basically, and we're just doing an operation on that, right? That's all we're doing. For example, look at this data frame we created. It's just basically apple, different fruit, apple, banana, orange, grape, pear, and their prices, right? So we're just going to create an object here, products, which I basically just can create 3 new columns, and I'm just basically just taking the price and doing different actions on it, right? A discount, a tax, a profit margin, and just returning this as our products data frame plus these 3 extra columns, right? Once again, I'm just doing an operation, directly a vectorized operation on the data frame instead of that silly loop, right? And this, so it goes to figure that, like, if we can do that with simple operations, we can do it with functions, right? Which is the whole point of R, once again, right? We can run functions on vectors. Wasn't that what I said the day one? Do stuff to vectors, right? So basically we have a vector, it's a column, and we just apply a function to each one of those columns, each one of those vectors. It's much easier and computationally faster, right? So let's say we have an object that is numbers 1 to 100. I just want to sum those numbers, right? This is just a vector. Think of it as numbers 1 to 100 straight down in the column. How do I sum those? Well, I just run the sum function on numbers, and that's my total. That's it. All I gotta do. I want to count. What are the grades, right? It counts each grade. How many of each ones are there? Well, if you can just table function just basically does a count of everything, right? So we table grades, and we have A, B, C, and it just told us which each one. But the point is we're running the table function on grades. If I wanted the square root of all the numbers at once, I can just do the square root function. Instead of doing that number squared, just run the square root function on that vector, and we get our answers there. We can also, use our summarize, what we've been doing, right? We have our data, and then we summarize these different columns, right? For the, the total, really the sum, the mean, the max, minimum of our sales. But the point is, we're running summarize to, you know what I mean? It's a double function, right? We're running the function summarize, and inside of that, we're running the function sum, mean, and max, and min on the vector sales. So we're running the function on vectors. And that's great. Sometimes you need loops. So one of the times you need loops. So there are a few examples when you need loops. One I could say is when you're trying to do complex things that are build up. It has to be just one simple action. If you're trying to sample these results, it's building up a complex layer that makes it hard to use the for loop. Another example is this Fibonacci sequence we're building. There's several different layers of the function, so it's not just one simple clear-cut thing. So that's why those are going to be times where you're going to have to use a for loop. But those things don't happen all that often. You can normally simplify things or restructure them into several different operations and just ping them to pipe them together. And so that's not something that really happens. But when you will use this, and there's no way to get around it, is when you're having to deal with multiple files. So let's say we want to bring in a CSV file and do a bunch of operations on that CSV file. It could be that, or we want to combine a lot of those CSV files. Like for example, when you download your TCGA RNA-seq data, a lot of times they give you one file for each different sample. So you got to pull in each one of those files and do stuff to it, right? So in this way, we have to have that for loop. It's not an operation on a vector; it's an operation on a file, right? So for instance, for file in list.files, for file in our list of files, read the CSV in and then do stuff, right? So that would be an example where, probably the most common example where you actually will need a for loop. So our last loop is our while loop. And it's basically just a condition, repeat until something happens. So keep going until this condition is met, right? So for example, let's keep counting until we reach 10. Or, 5, for example. It should have been a 5 there, right? So we basically start with counter 1, right? And then we say, while counter is less than or equal to 5, then do this, right? And then do this. And then just keep doing that until it's not that thing. So just keep doing this, repeat it until something breaks, right? So if we put in 1 here, 1 is less than or equal to 5, so we print counter equals 1, right? But then we say counter plus 1 equals 2, so now it's 2. So we go back around. 2 is less than or equal to 5, counter is 2. And then 2 plus 1 is 3. And then once again, 3 plus 1 is 4. 4 plus 1 is 5, right? But then 5 plus 1 is 6. So when 6 goes back into here, it's not less than or equal to 5. So the function breaks, it stops. And we just get these values. So we're just continuing until the addition is finished, right? Another example here. So let's just say our savings in weeks are equal to 0 to start with. You want to initialize your object, right? So while savings are less than 100, so that's 0, right? So savings plus 15 equals saving. So now savings is 15. Week is equal to 1, right? So we go back around. Savings is less than 15, right? So now it's 30, and now we're week 2. We keep going through this, and when we hit 8 weeks, we will find that our savings is going to be too high. So our last value will be our 7, right? Our 7 weeks to save 100. So he keeps going through once again, even though there's 2 variables, till savings breaks the loop, right? Now, unfortunately, there's no way to really. These keep going to conditional changes. It's kind of inherently stateful, and it's really hard to vectorize this. Really, the best way to do this is to restructure things, like I said, and then just put them back to back, pipe them. Or for example, if you know the loop length, you can do things like here, we use the per package, this walk function, and we're just saying, basically go 1 to 5 through this. Walk us down the function, right? But it's kind of trivial because we know the loop length, right? So we can make a function for that always, right? So the idea is the whole point of a while loop is you don't know the length. It just keeps going till it breaks, right? So unfortunately, if you have such a situation like that, you have to use the while loop. But going back, really, the for loop is the most common loop, and the ability to vectorize that by applying functions to vectors, which are usually columns of data frames in R, is what makes R, so powerful. So that's just kind of going over our basic programming. Now let's talk about how to build our own functions in R. And when I first started doing this, I really avoided it. And I thought it was really difficult, and it just looked like Greek to me. And now I can't imagine not doing it. It just simplifies your work so much to apply functions. And once you have a big slew of a big pocketbook or pocket bag of functions, you don't have to make them anymore because you've done it for everything. So let's just show you how to make one and show you how to build it up and from very simple to a little bit more complex, right? So basically, functions, we can say they're like recipes, right? They take in inputs and then they get an output, right? So let's do a simple greeting function. The way you basically line up functions, you have the name of the function, you have your arrow, then you have the function. This is a function, right? This is the function. So we run this, and there's no input here right now. So basically the function is just saying, I'm going to print hello there, right? So if we run the function, we don't need any input, we get the hello there. So what are we going to say hello to a person, right? Or to a certain value. Well, this is obviously a more obvious function that we would have in real life. We name this function greet person, and we have function here, and then inside here is the name. This is what goes in the input for our function to get our output, right? So now we want to print hello this name. So for whatever we put in there, we want to get this out, right? So greet person, right? If we put in Sarah, which is a character value here, it's just going to put Sarah there and get our answer. Same with John. It's just going to put John there, we get our answers. If we put in a vector of people, we would get several different values, you can imagine, right? So we're kind of leading up to. So let's do a function that actually calculates something. Really simply, like say we have a Celsius value, and we want to change it to Fahrenheit, which no one ever remembers how to do, at least in America. So let's make a function called Celsius to Fahrenheit and have the input be the Celsius value, right? And then we're basically saying we put in a Celsius value, calculate this. Celsius times 9/5 plus 32 equals Fahrenheit. And then after you calculate that, return Fahrenheit. So we'll get that value back, right? So let's test it right here. We put in a 0. That's going to return 32. We put in the 100, returns 212. But 25, we're getting 77 back, right? So the function's working, right? Let's take a little bit more complex one. We want to calculate a tip now. So we calculate tip function. The function, we have our input bill, but now I've put a condition where everywhere in this function, basically tip percent will equals 15. It's kind of trivial. I could just put 0.5 here, but just to show you how you can set these things up, I'm putting tip percent will equals 15 throughout the function if I have a value here. So these also can be two different inputs to go through, but let's just keep it simple for now. So we're basically putting in bill. We're saying tip is equal to bill times 10% divided by 100, which is obviously 15, right? So 15% times whatever the bill is will be our tip, and then we'll add that to the bill to get our total, and then basically we'll just return the answer in a form of a list. Where basically we want to say our tip amount is equal to our tip, our total bill is equal to our total, right? So let's just get this to say it, let's run it, right? So dinner, we're saying equals calculate tip 50. So 50 goes in here times 0.15, right? That gets us 7.5, and then we add 7.5 plus 50, we get 57.5. And then you see the list is returned. That's why we have our $2 signs and our list here of tip amount and total bill, 7.5, 57.5. And there you go. And just calculating a different, we can change the actual percent, right? Now, when we put the 25 in, we multiply by 20 divided by 100. So we multiply by 1/5 now, right? So that is just getting us our 5 value for our tip, adds it together, gets 30. So you can see how that kind of works. This is very, very simple putting in values. But what if we want to put in like an entire data frame to our function, right? So if we wanted to do that, we basically put our data frame completely in, right? And then we want to call the name of the column, right? And this can either be a specific name or a vector of column names. But let's start simple and just say the actual name. So describe column function. We have function, data frame, column name. Values are going to be equal to the data frame column name. So basically that's just when you put the column name in the data frame, you're going to get a vector of that column, right? And then our result is going to be returned in a list, and we're basically just running a function on each of those. We're getting the mean, the median, and min-max of that column. Simple as that, right? And then we're returning this result. So basically, if we use the amount cars data set, for example, we can call our describe function, describe column function, and put in our data frame, which is amount cars, and our column name we want to look at, which is mile per gallon. And here we get our result, a list of the different descriptive statistics for that column itself, right? We can also add new columns to that same data frame using a different function, right? So let's say if we have a data frame and we want to add new columns of mile per gallon category, which is a case when, basically just describing how good the mile per gallon is at each rate, and actually the weight category, because we're expecting maybe a lighter car gets better mile per gallon or whatever, right? So we're basically we put in our function, our data frame, right? We use mutate to form our two columns, right? And we use case when to assign our mile per gallon a different value, and then we use our if-else statement with weight. It's greater than 3 heavy if it's not light, right? Return these values. So really our first two columns are to be expected in our data frame, just our cars and our mile per gallon, and we're adding these 3 columns you see here. And it makes sense, so we're saying add categories, amount cars, so all we're gonna do is put the data frame in, and it's just getting, adding those columns on there, and we're just calling back these specific columns, so we won't have 100 columns here, right? Okay, Great. So now we kind of looked through everything. Let's put it together, a little more complicated, a little simple project, and look through a couple of practice examples here to apply this knowledge we've learned today. All right. So first, let's kind of make a little simple project here. So to do that, we're first going to make a simple data frame. First column is names, just these different students' names, and then they're going to have 3 columns where they have 3 different test scores, and finally an attendance column, which just shows their percentage, how often have they been, how often have they been attending class, right? So at the bottom here, we're expecting, our let's see, this is our intro data frame. You can probably kind of imagine that these are all our columns, right? So let's make our function. We want to calculate the final grade based on all of this stuff, right? So I want to enter the data frame, which will be our student data frame. I want to take that data frame and I want to mutate it to add a bunch of different columns here. I want to average out the tests, and then I want to assign a letter grade, right? Based on the average of these tests using case when. So I just take my average, then I apply the case when to see which grade it is. And then I look at an if-else statement, and I look at my average test score. If it's greater than 70, I do pass. Else, if it's greater than 70 and attendance is greater than, it has to fill both these things, right? Then pass. Else needs improvement. So if you break either one of these, you need improvement. If you pass both of them, and then you get pass, right? We're gonna have some bonus points. Once again, with an if-else, we're basically saying if you have 95%, then you get 5. Otherwise, you get 0. Right? Final score. Basically, we're just doing the minimum here. We're basically just taking it. We're just capping it 100 basically. So we're setting a max value, but we're just basically saying the average test plus bonus, and we're capping it 100. And that gives us our final score. And so let's run our actual function here. So we're basically putting our students' data frame in our function, and it's just going to get our average test scores, figure out the bonus, add those together to get our final score, and then return the letter grade in our pass-fail as we had there. And that by doing, we have our final grades, and we're just kind of ordering out these the way we want, and doing descending by final score, so we have the higher score on top. And we can also do a quick summary statistics of this. We take our final grades and we can summarize, kind of add some new columns here based on the scores, and we have some kind of descriptive statistics for the entire class, like class average, the highest and lowest, how many students pass, things like that. So this is really, you can see how, imagine if we have this function and then we could use it each month for our kids, or each class, different ones. Then we could make these calculations without having to do this over and over and over again each time. And you could use it every year. If you're teaching, if you built a custom thing, so you can imagine how you could do something similar for your own data. So you do kind of some simple things where you'd be able to speed up and automate your own work. So let's just apply this one more time, or a couple more times, do a couple practice exercises. We're gonna have 2 exercises here. One's gonna be a temperature converter, very similar to what we did before, just a little bit more complex. And it's going to go between Celsius and Fahrenheit. It's gonna work with single values or vectors, and then just gonna add some new categories and some visualization. So we kind of go through this. There's basically 2 main things here. We take in the temperature value from Celsius, or else we take it in from Fahrenheit. And we basically do if from Celsius, else do Fahrenheit, else stop, right? So if else, if it's an if else, right? Else if, right? So if else, then stop. Hey, we need to know if it's C or F. You need to tell us, and then return the result, right? So let's go through each one of them here and break it down. So first, we're going to have to create a kind of empty data frame to work with. So when you loop through and add things, you have to create like kind of an empty data set first. So we're basically going to say our original temperature equals our temperature we put in there. So it's just an empty data frame with our original temperatures. That's it. So we're going to if from C, which will be something we put in the actual input, take that temporary data frame and add columns, right? The first column will be Celsius, which is just our original temperature. Then we'll do the transformation to Fahrenheit. We'll add a case when, depending on the degrees in Celsius. It'll tell you, subjectively how cold it is. Another case when, it'll tell you when is this uncomfortable or moderate or whatever. Another subjective view of comfort. And then here we're gonna have to say, it's gonna have to do and these, and this, here we're saying it has to be this or this for the range low and the minimum and max there. And then one more case when, what should I wear based on the temperature? And then finally, we're just selecting out the columns that we want in the order we want, and then returning, right, the result. If we started with F, we do the same exact things, just from the other perspective, the other numbers basically, right? So that returns our result. So for instance, if we have convert temperature 20 degrees from C, we get print our answer, right? Here's our answer. Celsius, switch to Fahrenheit, and we have some of our categories here. Well, what about a vector? Will a vector work? So the whole point of this is to vectorize it, right? Yes, of course it'll work. We're basically doing it on a single value, that the single value is basically a vector. So we're putting in, we definitely can put in vectors. So we put in a vector of Celsius temperatures here, and we call it Celsius temps. We put it here from C once again, and then we have our results for each of our temperatures. Conversely, we could put in a value of Celsius, of Fahrenheit values, and say from F, and we get our Fahrenheit answers as well here. Now, what if you wanted to visualize this a little bit more for a bit? Well, let's take advantage of our input will be our temperatures from Celsius, our temperatures from Fahrenheit, you can imagine. And or basically just one is F here. It's basically just saying from C do this, else do the F, right? That's it. So there's not that one part that says stop ASCII. If you don't have Celsius, or this function is just going to break from the start. So we're taking advantage of our convert temperature. We put in our temperatures from whatever, and that gives us a data frame here. And then we're going to make a plot using that data frame. So we have data frame. Our GT plot will be X value Celsius, Y value Fahrenheit, and we're going to color by our category. So basically our category, remember, was cold, freezing, hot, blah, blah, blah. So we have Celsius along the X, Fahrenheit along the Y. We have our values printed, and they're colored by our actual category. We could have colored them by the coat we want or whatever, but we colored by category for here. We have our GM point. We can control the size. We have our GM text, basically to write Celsius, and we can adjust the size and the location here. V-adjust is vertical adjust. Then we add in 2 horizontal lines. Basically, we want to see where it's freezing and body temperature, and we're basically scaling these values to these colors. So there's our little horizontal lines here, our little GM text we've added, and our different names for our different labels. And we're basically returning P because we called each one of them P. And if we have our new visualized temperatures, we can put in a vector of our Celsius values from C, and we get our descriptive plot here too. So that's a pretty cool way, pretty simple way of seeing how you could organize a pretty cool function there. So let's do one more here. We're going to do a grade calculator. This basically creates a function that basically takes a data frame of student scores. It calculates the weighted average, right? And then it assigns a letter grade and identifies on a roll. Very similar to what we've done in the past, but we're just kind of being repetitive here to get our chops here. So we're basically making a function called process grades, and it takes an input of a data frame. And what a data frame is going to look like here is going to be name column, test column, homework column, right? So the names, test grades, homework grades, right? And we want your final grade from that. So first we pull in the data frame, and we're just mutating, and we're adding some different columns, right? First, we're going to add the weighted average of the test, of everything, I mean. So tests are going to be equal to 70%, homework is going to be equal to 30%. So that gives us kind of a weighted average between that weights test a little bit more. Then we're going to assign a letter grade using case when. So just once again, this vectorized case when, right? And whatever your weighted average falls, you're going to get your grade. Then finally, we're going to identify honor roll students using that vectorized if else. So we're basically saying if the weighted average is greater than or equal to 90, then true, they are honor roll, otherwise false. Same with pass fail, except now it's 60. If your weighted average is greater than or equal to 60, you pass, otherwise you fail. GPA points, very similar, we're doing our case when, and then we have, depending on where you fall, you get your GPA points, and then just some feedback where your weighted average falls, how are you doing, things like that. And then we're going to arrange this descending weighted average. So we want we want to do it by weighted average being the highest first and coming down. And then we want to return that result once again, right? So then we have our data frame, students, and then we have our function called process grades that returns the result. So we want to run our function, process grades, put in our students, data frame there. And we see here we get our results. We have our name, test, homework is expected. We have our weighted average, our letter grade, and our honor roll. And here we selected out the columns and we can order them however we want using tidyverse here. Now let's also create a visualization function of this as well. So basically our grade result is basically going to be what goes in here, the graded data frame. As you see here, grade results goes in. So that is our result. And we're just doing the library grid extra to kind of arrange multiple plots. And here, the first will be a grade distribution bar plot. And we're basically going to bar plot. X is going to be our letter grades, and they're going to be filled. And this is basically, so bar plot is basically a histogram, if you think about it. It's just a distribution bar plot, right? So we have just one value of X. The Y value would be the numbers, and fill will be honor roll. I'll give you kind of look at how that is. So you're basically just, in a way, it's just a density or histogram. So you have for each value, you have the number of students that have that, and then you have this filled by the status, right? If they're regular or honor roll. So you're filling by honor roll, right? And then you're basically just, your labels and your colors here. And that's where we're able to get our distribution of grades through the bar plot. And then second, we want to do a scatter, let's actually want to do a weighted average histogram first. So that was kind of our bar plot, but it wasn't in the histogram style, right? So next we wanted to look at the weighted average of scores, right? And we wanted to do a histogram of the weighted average on the X value, and the fill will be by performance. So here, our weighted average is here. We have our different counts, our different bin counts, and we have our performance that we have filled in. And we built a vertical line here at 90, saying everything above that is the honor roll cutoff. And I'll show you how I built that here. So ggplot first, set the background, right? X equals weighted average, fill by performance. Now we just have the clean slate in the background, right? Then we add the GM histogram and our number of bins. We have the GM vertical line at the interceptor at and the color and line type, right? And then we scale all of our different colors and that are in the performance. We put in our manual colors for those, and then we add our labels there. And that's how we're able to get this plot here. Let's see. So third, we'll do our scatter plot. It's a very, very simple scatter plot with X is tests, Y is homework, and we're going to fill by the letter grade, right? And then we add our GM points just for the size of our points and the transparency. GM smooth to get a linear model, kind of a linear regression line through. We're going to call it, we set the color and the line type. Then we add our GM text, which is just adding our labels and our, a lot of different labels that go around here. And here you see this, test score is X value, homework score is Y value. We have our distribution that's colored by letter grade. And then we have our linear model, our regression line that we set apart. And Our last plot will be our individual student comparison, so we want to compare each student's, and we want to, basically the x value is going to be, we want to arrange by the descending weighted average. So we're going to see a plot, we're going to make a bar plot, and it's going to descend by the actual weighted average. We're basically making a new plot here, a new data frame, where we're mutating, and we're saying the name is equal to the name, and then so now we have our basic data frame, right? We set up our ggplot, our background, x equals name, so our different students, y equals the weighted average, right? Which what we're trying to, we set up as descending, and our fill is honor roll. And you'll see here, our students are x value, our y is weighted average, it's descending, right? And our fill, orange, or yellow to gray, is by honor roll, right? And then we're setting up two horizontal lines here, one at passing, one at honor roll here as well. So just to walk you through it one more time, we've arranged weighted average descending. We've created a new column called name, and basically just factored the names. So each name is a factor. We've created our background ggplot with our x equals the name, our y is equal to weighted average, our fill is by honor roll. Then we've called gm column. We could have done gm bar identity, equals identity, but we've done gm column because we know that it's a bar plot rather than a histogram that takes in multiple values. We set our gmh lines at 90 and 60. We set our gm text, just controlling our text within the graph, and then we have our scale manual fill values, and regular and honor roll are basically given their gray and yellow color. And then we've done our labels here, where we've set all our labels. So this gives us a good visualization of our letter grades, our score distributions, our performance in test versus homework, and our student rankings. So this is a pretty good overall way of looking at this data cohort using functions. Just to go back, kind of a quick reference, to remember, if you have if by itself, just one thing, like a condition, if this, then just use the if statement. That's okay. If you have two things, an either or, use if else. And instead of using the loop method, use the if else vectorized version, right? If you have multiple conditions, you can either use the loop method's many if else types, right? And our version uses case whens. If it's just vectorized for loops, here, just use the function. Just apply the function to the vector. You don't have to for loop that, right? And then if you, for instance, like the sum x, just don't worry about for loops. Vectorize them, right? And the only place you really want to use for loops is really bringing in files, multiple files, back to back, right? Otherwise, your for loop should just be functions applied to vectors. And you can use things like sapply, or in the next lesson, where you can sapply a function. Basically, just applies a function to every column that you annotate. And so if you have a while loop, kind of have to use those. Unfortunately, those are the ones that are very hard to vectorize unless you know the loop length, which is trivial in itself, right? And if you want to loop through rows, you can use mutate to add new columns and things to your data frame operations. Things you can always do to help out is I haven't really talked about this much, but start simple. Make a little tiny matrix, a 3x3 matrix, 5x5 matrix, and play with these things. Don't jump into the full numbers first. Just start really simple. Start some very simple examples so you understand what your functions are doing. Try to use vectorized operations when possible, because they're faster and cleaner, and you're really taking advantage of the properties of R. Obviously make sure to comment your code to where you know where things are and what things are doing, so you don't get lost or forget. The worst thing you can do is create a problem, to fix a problem, and then forget how you solved it. Test often to catch errors and ask for help, right? One of the ways to learn programming the best is just to ask for help, right? Ask me for help, ask ChatGPT for help, ask Google for help, ask the forums for help, right? Stack Overflow. Trying to figure these things out yourself, you will learn faster than just getting someone else to do it for you. Food for thought. And then we have an initial assignment that I've given you, kind of as a pseudo homework. Feel free to go through it here. We're basically taking the automobile data set, and we're just basically creating a data cleaning function. We're building some custom analysis functions just to compare different things in the data set. We're trying to use vectorized operations throughout. And then we're also going to create 4 different visualization types, like a scatter plot, box plot, correlation heat map, things like that. And so you're kind of just going to go through and looking at different parameters, compare different functions to look at different distribution of different values, kind of just descriptively look through the data set, and then create a report at the end. And feel free to go through this. I have all the answers there. If you get stuck, try it on yourself. Just look at the answers. That's helpful too. It's not the end of the world. Part of R is just looking at answers and cutting and pasting them to you one day remember them. So that's totally cool too. And for additional resources, these are just great resources. Once again, this R for Data Science book that was made by Hadley Wickham too really has a good way of going through R with using the tidyverse. I think it's just a very, very good book, and the first book you really should go through to start with. And once you get through that book, there's an advanced R book that basically builds upon that R for Data Science book. Learn a lot of new features. Go through those cheat sheets. They built all those cool cheat sheets for you in tidyverse, diplar, ggplot, all those. Make sure you go through those. If you want to learn about R markdowns, I have I put up a guide for that as well, and feel free to go through that and try to make your own markdowns. Keep looking through the tidyverse documentation, and just keep at it. This is basically the conclusion of our R Bootcamp. I hope you guys have learned a lot. I know it was only 4 weeks, so it's a big push. Try to throw a lot at you. We could go the whole semester just learning R. It's taken me years to learn, so don't feel bad if you get lost. And going forward, we're going to do things like start applying R to statistics, to machine learning, to apply bioinformatics. As we start using R more and more in your own work and your own projects, that's the way to best develop your skills. And just use this as a foundation to make sure you've seen things. Go back through these different R markdowns, and when you're lost, go back, check out my videos. Everything you need is here. Just go back, cut and paste it into your work and adapt it. And good luck, and keep practicing, and you got this. Keep learning.